Java and Python are popular programming languages used for a wide range of applications. Both have stood the test of time and have evolved significantly since their inception. Java, created by Sun Microsystems in 1995, has been a staple in the programming world for decades. Python, on the other hand, was conceived by Guido van Rossum and released in 1991. Despite their age, both languages continue to be relevant and widely used in modern software development. They are both powerful and versatile, but they have key differences. Java is a statically typed language, which means that variable types are explicitly declared and checked at compile time. This can lead to fewer runtime errors and more optimized code. Python, in contrast, is dynamically typed, allowing for more flexibility and faster development cycles, but potentially more runtime errors. Understanding these differences can help you choose the right language for your project. For instance, if you are working on a project that requires high performance and scalability, Java might be the better choice. Its strong typing system and performance optimizations make it ideal for large-scale applications. On the other hand, if you need to quickly prototype or develop a project with a focus on readability and ease of maintenance, Python could be more suitable. Java is known for its speed and efficiency. Its just-in-time, JIT compiler, and robust memory management contribute to its performance. Java's architecture-neutral nature allows it to run on any device that has a Java Virtual Machine, JVM, making it highly portable. It is often used for building large, complex systems, such as enterprise applications and Android apps. Java's strong typing and object-oriented features make it a reliable choice for developing scalable and maintainable software. Many financial institutions, e-commerce platforms, and large corporations rely on Java for their back-end systems. Python is known for its readability and ease of use. Its simple and clean syntax allows developers to write code that is easy to understand and maintain. Python's philosophy emphasizes code readability and simplicity, making it an excellent choice for beginners and experienced developers alike. It is a popular choice for data science, machine learning, and web development. Python's extensive libraries and frameworks, such as NumPy, Pandas, TensorFlow, and Django, provide powerful tools for these domains. Data scientists and machine learning engineers often prefer Python for its ease of use and the vast ecosystem of libraries available for data analysis and modeling. Both languages have large and active communities. These communities contribute to the continuous improvement and evolution of the languages. They also provide support through forums, user groups, and conferences, fostering a collaborative environment for developers. This means there is a wealth of resources available to help you learn and use them. From online tutorials and courses to books and documentation, you can find a plethora of materials to guide you through your learning journey. Websites like Stack Overflow, GitHub, and Reddit are also valuable resources for finding solutions to common programming challenges. Whether you are a beginner or an experienced programmer, you can find plenty of support online and in print. Many universities and coding bootcamps offer courses in both Java and Python, providing structured learning paths for students. Additionally, numerous online platforms offer interactive coding exercises and projects to help you practice and improve your skills. This essay will compare Java and Python in detail. We will delve into various aspects such as performance, scalability, ease of use, and community support. By examining these factors, you will gain a comprehensive understanding of the strengths and weaknesses of each language. We will explore their strengths and weaknesses to help you determine which language is best suited for your long scripting needs. Whether you're developing a web application, a data analysis tool, or a mobile app, understanding the nuances of Java and Python will enable you to make an informed decision and choose the right tool for the job. Java and Python differ in their programming paradigms. These paradigms shape how developers think about and structure their code, influencing everything from the design phase to the final implementation. A paradigm is essentially a framework or a set of principles that guide the organization and structuring of code. It dictates how problems are approached and solved within a programming language. Java is primarily an object-oriented programming, or OOP, language. This means that Java focuses on creating objects that represent real-world entities, encapsulating both data and behaviors. Python, on the other hand, is a versatile language that supports multiple paradigms, including OOP, procedural, and functional programming. This flexibility allows developers to choose the most appropriate paradigm for their specific needs. OOP is a powerful way to organize code into reusable objects. These objects can be thought of as self-contained units that bundle data and the methods that operate on that data, promoting modularity and reusability. These objects contain both data, often referred to as attributes, and methods, which are functions that operate on the data. This encapsulation helps in managing complexity by keeping related data and behavior together. Java's strict adherence to OOP can make it easier to manage large code bases. By enforcing a consistent structure, Java helps developers maintain and scale their applications more effectively. Python's multi-paradigm approach offers more flexibility. Developers can switch between paradigms or even combine them within a single project, allowing for a more tailored approach to problem solving. Developers can choose the paradigm that best suits their needs for a particular task. For instance, procedural programming might be ideal for straightforward, linear tasks, while functional programming could be better for tasks that require a high degree of mathematical computation. This can be advantageous for projects that require a mix of programming styles. For example, a project might use OOP for its core architecture, procedural programming for simple scripts, and functional programming for data processing tasks. While Java excels in large, object-oriented projects due to its robust OOP features, Python's flexibility makes it suitable for a wider range of programming tasks. This includes web development, data analysis, artificial intelligence, and more. The choice between Java and Python ultimately depends on the specific requirements of your project and your preferred coding style. Consider factors such as the complexity of the project, the need for scalability, and the types of tasks you need to perform. It's also important to consider the existing skill set of your development team. If your team is more experienced with Java, it might be more efficient to stick with it, even if Python offers some advantages for the project at hand. Both Java and Python have strong community support and a wealth of resources available. This means that regardless of which language you choose, you'll have access to extensive documentation, libraries, and frameworks to help you along the way. Another consideration is the long-term maintenance and updates of your code base. Java's strict structure can make it easier to maintain over time, while Python's flexibility might require more careful management to avoid potential pitfalls. In conclusion, both Java and Python have their strengths and can be the right choice depending on the context. Understanding the paradigms they support and how they align with your project needs will help you make an informed decision. Ultimately, the best approach is to evaluate your project's requirements, your team's expertise, and the specific advantages each language offers. With this knowledge, you can choose the language that will best support your goals and lead to a successful outcome. Java and Python also differ in their typing systems. Java uses static typing, while Python uses dynamic typing. This fundamental difference affects how you write and debug code. In statically typed Java, you must explicitly declare the data type of each variable. This means that when you write your code, you need to specify whether a variable is an integer, a string, a float, or any other data type. The compiler then checks your code for type errors before it runs. This process, known as type checking, ensures that the data types you have declared are used correctly throughout your code. This early error detection can prevent runtime surprises, but requires more upfront code. By catching errors early in the development process, you can avoid many of the pitfalls that might otherwise occur during runtime, such as type mismatches or unexpected behavior. On the other hand, Python's dynamic typing allows you to use variables without declaring their type. This means you can write code more quickly and with less boilerplate, as you don't need to specify data types explicitly. The interpreter determines the type at runtime. This flexibility can be a double-edged sword. While it speeds up development and makes the code more concise, it can also lead to runtime type errors if not handled carefully. This flexibility speeds up development but can lead to runtime type errors if not handled carefully. For instance, if you accidentally use a string where an integer is expected, the error will only be caught when the code is executed, potentially causing issues that are harder to debug. Static typing in Java enhances code reliability, especially in large projects, by catching type errors early on. This is particularly beneficial in complex systems, where the interactions between different parts of the code can be intricate and difficult to manage. Dynamic typing in Python allows for faster development and more concise code, but requires careful attention to data types during development to avoid runtime errors. Developers need to be vigilant and often use additional tools or practices, such as unit testing, to ensure that their code behaves as expected. In summary, the choice between static and dynamic typing depends on the specific needs of your project. If you prioritize early error detection and code reliability, especially in large and complex systems, Java's static typing might be the better choice. However, if you value development speed and flexibility and are willing to manage the potential for runtime errors, Python's dynamic typing can be a powerful tool. Each approach has its own strengths and trade-offs, and understanding these can help you make more informed decisions in your coding practices. When it comes to performance, Java has a clear advantage. As a compiled language, Java code is converted directly into machine code that the processor can execute directly. This results in faster execution speeds, making Java suitable for performance-critical applications. Python, on the other hand, is an interpreted language. This means that the code is executed line by an interpreter. This process is generally slower than compiled code, but Python's performance can be optimized using techniques like just-in-time or JIT compilation and using libraries like NumPy for numerical computations. While Java's inherent speed makes it a powerhouse for demanding tasks, Python's optimization options and libraries like NumPy can significantly boost its performance, making it suitable for many applications.